when we factor expressions, we are using the distributive property. And we've already used the distributive property when we have a number times some expression. We multiply that number outside the parentheses times both terms inside the parentheses, like this. We show the rainbow. 3 times x would be 3x, and 3 times 1 would be positive 3. All right, we can picture it like an ice cream cone. If I had an ice cream cone times cookie dough ice cream plus vanilla ice cream, when using the distributive property, we're putting things together. So let's picture this cone. I'm going to put the cone on the cookie dough ice cream, and I'm going to put the cone on the vanilla ice cream. And so I could say I'm distributing. So the cone times the cookie dough ice cream would give me a cookie dough ice cream cone, right? I would have the cone, and then I add the cookie dough on top of it, right? So there's my cookie dough ice cream. I also distribute the cone to the vanilla ice cream. And so I would end up with a vanilla ice cream cone. There's my cone. Here's my vanilla ice cream. Right? So when I distribute, I am putting things together. Now, when factoring, you are essentially doing the reverse distributive property. You are, instead of putting things together, you are taking them apart. And so let's continue with our ice cream cone example. Let's say we start with the ice cream cones already made, and we want to take them apart. When you do this, when you factor, you are looking for, what do these things have in common? What is the greatest thing that they have in common? Or we could say the greatest common factor. Well, both of these ice cream cones have the cone in common, right? And so what I'm going to do is I'm going to pull that out. I'm going to take that out. I'm going to say that they both have the cone in common. I'm going to pull that out. Now, after I pull that out, what am I left with? If I take the cone away, if I take this cone away and this cone away, what am I left with? Well, I am left with the cookie dough plus the vanilla ice cream. So what I can say is I have the cone times the cookie dough ice cream plus the vanilla ice cream. Right? And as you can see, that is what I started with. That is what I started with back up here when I distributed. So when I factor, I'm using the distributive property still. It's simply like the reverse distributive property. I am undoing what has been done. I take out what they have in common, and in parentheses I put what is left. Let's do a few examples. The first example here, I have 16 plus 44k, and I want to factor this. So what do they have in common? What is the greatest factor that they have in common? Or I could say, what is the GCF, the greatest common factor between 16 and 44k? Well, if I don't know, I can use what is called the ladder method. Ladder method to figure out the greatest common factor. And to use the ladder method, I would write those numbers side by side. So 16 and 44, and draw an L for ladder. I'm going to pull out a common factor. They're both even, so I know they have a factor of 2. 2 times what is 16? Well, that would be 8. And 2 times what's 44? That's 22. Do 8 and 22 have a common factor? They do, right? Because they're both even, so they have a factor of 2. I pull that out. 2 times 4 would be 8, and 2 times 11 would be 22. Now, 4 and 11 don't have a common factor other than 1, and so I'm done making ladders. And to find the GCF, here's what I do. I go straight down. I go straight down and multiply those numbers together. So 2 times 2, that would be 4. So the GCF of 16 and 44 would be 4. That is the greatest factor that they have in common. Therefore, I'm going to pull that factor out. Okay? And then inside my parentheses, I need to multiply 4 times what would be 16? Well, that would be 4, right? 4 times what would be 44k? Well, 4 times what's 44? Well, that's 11, right? Positive 11. And then I need a k so that if I were to take this expression and distribute, I would have 4 times 4, which is 16, and 4 times 11k, which is 44k. So this right here is my factored expression. Next example, I have 48 plus 84c. Let's find the greatest factor that 48 and 84 have in common. So to do that, let's use the ladder method, because off the top of my head, I don't really know what that is. So I write those numbers side by side. I'm going to pull out a common factor. I know they have 2 in common because they're both even. 2 times 24 would be 48, and 2 times 42 would be 84. Again, they're both even. I pull out a common factor of 2. 2 times 12 is 24, and 2 times 21 would be 42. 12 and 21 have a common factor of 3 because 3 times 4 is 12, and 3 times 7 is 21. But 4 and 7 don't have a common factor other than 1, and so I'm done making ladders. To find the GCF, I take those numbers on the left side right there, and I multiply them. 2 times 2 times 3, that would be 12, right? So my GCF is 12. I'm going to pull that 12 out, and then in parentheses here, I'm going to think to myself, 12 times what would be 48? Well, that would be 4, right? 12 times 4 is 48. What about 12 times what is 84? Well, that would be positive 7, right? 12 times 7 is 84, and there's a C there, so I have to add a C so that if I were to distribute, 12 times 4 is 48, and 12 times 7C is 84C. So this is my factored expression. One more example here. We have 45K plus 10. Okay, what is a common factor between those two? Well, this ends in a 5 and that ends in a 0. And so I know that they're both divisible by 5, and in fact that is the greatest common factor. 5 is the greatest common factor. So I'm going to pull that factor out. Okay, then in parentheses, 5 times what would be 45K? Well, I know 5 times 9 is 45, and it has a K in it, so I got to add a K to that, so that if I were to multiply 5 times 9K, I would get 45K. And then 5 times what is positive 10? Well, that's positive 2, right? 5 times 9K is 45K, and 5 times 2 would be 10. So this is my factored expression.